train wreck. That's how it's.
Okay, put your hand in there.
Helm.
No, put your hand. Let's try to see if we can stop it. Yeah.
I swear you could. But I want to see the type of system we have in here.
Yeah, nice.
This is another way. The bigger the company is, the more space they choose. Oh. You got this is dope.
It's network too.
Yeah, that's network. Imagine if you can.
So this is when it gets crazy. When you have like over 1,000 of these doing the same thing, 1 second they'll be making thousands of it, whatever they have to make.
So you're working directly with that, or is there a sales team?
Jason Lewis.
Jason Lewis.
Jason's right. Yep. Yeah, we
Cool.
Yeah. Gus Robles.
See how fast it goes.
That's probably why it's protect people. Because I guarantee you, some of those people, they're gonna be like, hey, you touch it, and the next thing you know, they cut off their hair.
Where you with? Oh, okay. In a robotics technology program? Or?
We're actually students, but we work. So could you tell me a little bit about what this machine is, what kind of programs are?
Sure. So this demo obviously is a golf demo, so just demonstrating the capability of our SCARA and our 6-axis robots. Yeah, sometimes I think it gets stuck. So
It gets stuck in there.
yeah, we don't have a vision on here to verify that the part is there or not. But the way these are programmed, have you taken like a programming class like basic? Okay, so it's a text-based language. It's called, SCOL, SCOL. It's a proprietary to Toshiba machine, but it's text-based, so it's very straightforward. The syntax is very easy. So it's line by line. It would be something like, move here,
Steps,
move
like
to
a
this
sequential
point,
kind
move to
of.
that point, yeah, line by line. And then, have you had any ladder logic classes, like for PLCs?
Yeah, we actually do that.
Okay, so there's, inside the controller is also an internal PLC. It runs on a separate processor from the robot. So the robot is programmed in this text-based language, and then the PLC is programmed in a ladder logic. Yeah. And there's like 32 inputs, 32 outputs on the PLC, and there's some expansion capabilities too. Yeah, so depending on the application, and how many inputs and outputs you have to control, you may not need a separate PLC because you can do it all within one controller. And then there's inputs and outputs dedicated to the end of the hands, the hand I/O.
The PLC is not the one controlling the arm though.
No, it's a different,
Different program.
processor. So yeah, they run completely separate, but they can communicate with each other through I/O. Yeah. Yeah, and so on the robot side, the commands are like, move, wait, D in, D out. So if you want to control a digital output, you just say D out, at the input point. If you want to wait for an input to go high, you would say D in, 1 or something. So it means you're waiting for input point 1 to go high before you go to the next slide. Yeah, you can do, there's like for loops and do loops.
Yeah.
You can do those kind of things.
Nice.
So, yeah, it's pretty straightforward.
And are you guys based? Like, are you guys from Minnesota?
I'm from Minnesota. I'm with, give me my card.
That is cool.
I'm with Werner Electric, and so we are a distributor of this product. We work with customers to train them on the capabilities of the product and how to program it. And then the company itself, the American headquarters is in Chicago.
3 to 4 days.
That's where we get our training.
So, like, what are some of the things that it's using to operate? Like, what are some of the programs?
So the trick here is, I'll wait a little quick until it's display with a Qt interface, but it also has a microcontroller in here that can take care of the balancing. So it's basically what we call a heterogeneous multi-core system. So you have 2 different processors in here for 2 different tasks. One does the balancing and the other one does the user interface. So when I turn this guy on, it immediately starts balancing because we're downloading the software for the balancing algorithm, but you can see the Linux is still booting. So while it's now booting, your system is already running. It can already be safe, handle safety critical tasks. But your user interface might take a while to boot, which is okay because that's not that critical. The critical task is to make sure the robot can stand up, right? And then once this is basically loaded, you can also communicate between the Linux operating system to the microcontroller via this controller. So, I could move him around because the position is controlled by the microcontroller, and this is connected to the Linux. I can now send him comments and say move forward or move backwards and so on. So it's just kind of like a little demo about our boards. I mean, we sell those computer boards, and they typically go together with these kind of development boards. And can be used for any kind of industrial controller or industrial application.
Grab something in there.
I don't know.
I grabbed it the last month.
No, you can. It's the show.
Oh, so every school gets it, huh?
Yeah, I think if you're a teacher, you can get one.
For free, huh?
Mm-hmm.
Because obviously this.
You're tripping it.
Am I?
Oh, am I?
Okay. Too late. Push it again. He's trying to game the system.
Trying to cheat.
He's defending the system. Yeah.